Hello guys, welcome back to another video. In today's video, I'm going to be talking about linked lists. So, today we're only going to be talking about one type of linked list, and that's called a singly linked list. So, SLL. So what is a singly linked list, you ask? Well, technically, it's when you have a head node and it's connected to more and more nodes. And these nodes can only be connected one direction, from head to the end. So you cannot go back. And so there's just unlimited amount of nodes you can have, and they can only point one direction. And they're not connected. They're only connected one way, so they cannot go back to the beginning. They're only connected to the next node. Okay? So that's a brief description about link. So these here are called pointers, and these are the nodes. Now you can consider the first node as a head, and you can consider this last node as a tail. So that's a brief explanation about singly linked lists. Now let's figure out how we can implement this as a class in Python. So let's open Sublime. Okay, cool. And here I'll just call a class. First, I need to save the file, of course. We can call this a singly linked list. Dot. Here, I'll save it in my. There you go. Singly linked list.py. There we go. So now we created our file. Let's call this class singly linked list, as the name says it is. Okay. And here, let's create a method, initialization method. We can have a variable. So we can have we can put our head node. By default, let's set this as none, because the user might not be able to input at that time, so that's useful. So you can say self.head equals head. Actually, you know what? Let's just set this as not. Okay. So we can say self.next, because we are pointing to the next node. We can say this is none. Okay. So head points to next node, it would be none. Cool. So you can only move one direction, so we have this variable in place. I would say we could probably do this and go like that. Cool. Now let's create a function called insert, but self. So let's insert our node. We should probably input node here. And in here, we can actually just say if not self.head. Well, we actually don't have self.head. So we can say this is not. If not self.head, so if not none, then we get node. We can say self.head equals the node. Else we can look at. We can say a while loop. So while true, and then we can say if. We can create a variable called current equals to self.head.next. Cool. And we can say if current is not equal to none, then we can say current.next. So we can continue. Cool. And then else we can say so if it's equal to none, then we can say current equals to node, meaning now none will be node. Cool. So that's it, and then we can return false. And now our node is added. Nothing else. So that is the insert function. Now let's talk about printing, how we can print. We can just say define ret. You can say self node. And here we can say print actually up here we should create a variable called self dot value. And here we can say current dot value equals to node. Great. And up here we can also say current dot value isn't equal to none instead. That makes more sense. And also if not head self dot value head dot value equals to node. Great. So now we have that. The only thing I can see here is we can say self dot head dot value. No, we can put self dot head dot next. That's fine. Okay. So we have current x, current value node. Great. Now in this return function we can keep saying we can print while true. We can create a while true variable, and we can say if actually up here we can just say we can remove this node, and again we can create another current variable equal to self dot head. If current equals to none, then we can just say return false. Else we can say current dot value, or we can print this current dot value, and down here we can move to the next. So we can say current dot next. Great. So now we have returning. Now that seems basically it. If we want to remove, we can do that easily. We're not going to use a specific node, we're just going to remove the last. So we can say very similar, current equals self dot head. And then we can say while true. And then we can say if current equals or we can say actually we should say if current dot next equals to none instead, then we can say current itself equals to none. Current dot value equals to none. I meant to say. There we go. So now we have that. And else we can say current dot next. And inside this if loop we can also say return false. So what this means is we can check that its next node is none, meaning it has no children, and so it should be none too, removing the last element from the linked list. And we return false so that we can end this while loop. And here we're moving to the next, so we can keep looping to find the last element. Great. So now we have that. We can also create a function that we can insert at the beginning. So below this insert function, we can create a function called insert begin. I think that's a better word. Yeah. And up here we can put insert end instead. Up to you, you can add this function, optional. But basically we can have a function insert beginning. So let's make sure we add this node variable So what we have to do is kind of change the pointers. So node should now be the head. So what we could do is we can create a temp variable equal to self.head. Great. Now we can say node dot next is equal to self.head. Great. Or actually we can say node.next equals to temp instead. And then we can say self.head equals to node. So now it's the head. Great. So now we have insert beginning up here, and now we have insert at the end. So we can just say return. Cool. So we have insert beginning, insert end up here, and I think that's it. We don't have to change any pointers about the head, which is a benefit with classes. You don't have to change the pointers for head. Cool. Now what we could do is we could create another function. I know a lot, but we can create a function called index. Okay. So it's similar to a list, but we have like a counter or something. And so we should have a variable node again, like most functions. Oh, this should be removed and great. So this index should be able to give you an estimate amount of how far it is in the list. Now we're not going to do like list index 0, 1, 2, 3. We'll just put 1, 2, 3 so you can see what position it is in. So we can do that. So let's create a counter and let's set that as 1 by default. Okay. And 1 should be the first element, which is head. Okay. So we can say if not head, return -1, because you can't really find indexes with it being empty. Else, if we can say if node.value, which is the variable up here, self.value. I forgot to set this as none, my bad. But here we can say if node.value equals to self.head dot value, very important. We can say return 1. Okay. Else we can say while true. And again, we can create a current variable equal to self.head, which is good. And here we can say if current dot value equals to node. Actually, here we should actually say self.head of next, because then we're actually starting at the next node. Well, the least we can do is probably just check to make sure that exists. So we should say if current dot value is not equal to none. Great. Now we can put current dot next. Or no, we should also check if node is equal to this current dot value. Or actually we should put it as a condition. And node equals to current dot value. Right here. Cool. Node of value, I meant to say. Great. So now we have this condition. With this we can just say hold on. And also set CTR plus equal to 1, like that. And we can say return CTR. Otherwise, elif dot value isn't equal to current dot value. Return can return hold on. Yeah, we can return hold on. We can return actually we can say if it's not equal actually we should put a condition saying that if it's equal if current dot value is equal to none, then we should return -1 else. This condition, that means this is false, so we can just ignore it. Because we're moving to next and we're putting CTR as 1. So that's the thing. We're moving to the next one. Great, so this is our function. Here we return CTR. So it doesn't really matter about this while loop. We're actually just returning, so it's done. That's basically it. These are my optional functions for a tree, singly linked list, and I hope you enjoyed. Please let me know down below if you want to see more functions for singly linked lists, and I'll be sure to make more videos on doubly linked lists and circular linked lists, which will be after this. Okay? Cool. So, thank you guys so much for watching. I hope you enjoyed. Hope to see you in another functional video. Peace.